Hello, friends. So I'm going to show you real quick how to calculate, this is so confusing for me, the force of gravity using Newton's laws between planets. Not really that tricky. It just looks tricky if you're not used to it. Hopefully you've been working on this set of problems, the practice problems, Newton's laws. There's a new set that will be posted on November 3rd. So make sure you use these same formulas and methods to do those questions. There'll be another video too following up about Newton's version of Kepler's third law. So make sure you check all that. Let's do one of these real quick, and I'll just walk you through it and how to do these calculations. First, you want to start with your formula. Of course, always when in doubt, go back to the original formula, write it up first. That way you can write out all your knowns and steps, and always have that there in front of you. It will definitely help. So F is just the gravitational force. That's how much force there is between the two bodies. G, big G, is 6.67 times 10 to the negative 11th meters cubed per kilogram second squared. This is a constant. It's the universal gravitational constant that Newton discovered. How he did that, I don't know. You think, he was at home, there was a plague. Maybe you guys are clever. I don't know. Something's going to come out of this. He worked this out. And then the M1 and M2 are just the mass of the two bodies, and R is just between them. Newton realized that there was the same amount of force pulling on every object between every object with every other object. And it's all based on the mass of the two objects, their combined multiplied masses, and the inverse or division by their radius squared. So that's all we have to do is calculate through that. So in question 4 in this problem set, it says calculate the gravitational force between the following two objects. The mass of the first object is 5.71 times 10 to the 21st kilograms. So always go back and write down your knowns and your unknowns. We have G. So we're going to just write on here M1. Let's use a better marker. That'll be maybe a little sharper, a little easier to read, I hope. Pull you in a little closer, huh? Yeah, here you go. So M1 is equal to 5.71 times 10 to the 21st kilograms. And M2 is equal to 4.9 times 10 to the 18th kilograms. And then our distance is 30.5 times 10 to the 4th kilometers. Now, yeah, that's not good scientific notation if you're a chemist. But in astronomy, we play with those numbers. We don't really care because we're always interested in measuring things of thousands of kilometers or 100 millions of kilometers. Just roll with it. When we get a chance, maybe in a Google Meet, if you guys show up for one, then we'll talk about all that. But catch this. This is in kilometers. Here, your units in meters. So you have to either change this, the cubed meters, into cubed kilometers, which you don't want to do. Or you can easily flip this just by multiplying by 1,000 meters per kilometer. And you get 30.5 times 10 to the 7th meters. Because it's the same number. It's the same amount of space covered. It's just a smaller division of those measurements. So we can work it out faster. And our units match then. So they'll cancel out when we need them to. Now, we just plug all this into the equation. So we say F is equal to 6.67 times 10 to the negative 11th meters cubed per kilogram second squared times M1, 5.71 times 10 to the 21st kilograms times 4.982 times 10 to the 18th kilograms over 30.5 times 7 meters squared. When in doubt, use parentheses. Anytime you put a scientific number that's in scientific notation into your calculator, use parentheses. It'll help the calculator know what order to do the operation. If you leave the parentheses off things, it gets kind of sticky and makes little mistakes because the calculator says, well, it says in this order, but you don't mean it in that order. Put parentheses around it. When in doubt, just put parentheses around your number when you put it in the calculator. In fact, put them on here. It'll make it cleaner in your head when you punch it in the calculator. I know this from experience. So we multiply those together. We square that number on the bottom. We get F. And you should do this step by step, of course. If you're doing this for bridge, and I hope you are, please write it out by hand and just take a nice, neat photo of it. I'll dig through it. It'll be hard, but I'm sure I'm capable. And then when we multiply these together, you should get, and I hope you're doing this with me, 2.844722 times 10 to the 40th kilograms squared. Please note, you're taking kilograms times kilograms. So they've got to be squared. You got to keep track of your units. It's really important because we're trying to very carefully describe things here. When we take the square of 30.5 times 10 to the 7th, you should get 9.3025 times 10 to the 16th meters squared. Then you just divide this number by this number. Again, force is equal to 6.67 times 10 to the negative 11th meters cubed per kilogram second squared times, and we divide those, hopefully you got 3.058018812 times 10 to the 23rd kilograms squared over meters cubed. I'm sorry, meters squared. My bad. Meters squared. Now, at this point, I would want to start to cancel some of my units out to make sure I'm getting the right unit. Odds are 99% of the time, if you've got the right unit, you've got the right answer. So we have meters by meters here, and they cancel two of these, leaving us with 1 meter. We have 1 kilogram here. It takes out one of these, so we're left with 1 kilogram. Is that the right unit? You better believe it, because it's kilograms, meters, seconds squared, which is equal to 1 Newton. Remember, 1 Newton of force is equal to 1 kilogram meter per second squared, or the mass times the acceleration. Ta-da, mass times acceleration. Easy peasy. Now we multiply these two numbers together. And again, when you put in your calculator, pop parentheses around that. It'll help keep all that neat and clean. And you should get a force equal to 2.039698548 times 10 to the 13th kilogram meters per second squared. Just here's the real trick. Go slow and deliberate. Write out every step. So if there's a mistake, you can go back and figure out where it happened. But if you don't write out every step, you just program this all into a programmable calculator to spit this out, there's a good chance you miss something and you're not learning the methodology or the thought process that goes with this. And that's the key thing, is to learn the thought process. So go back, do these slow and deliberate. And if you have questions about it, email me. Until then, good luck and keep looking up.